We've spent quite a bit of time now talking about integration, starting with indefinite integrals, then definite integrals, looking at some different integration techniques. Along the way, we've mixed in some applications, but now in Module 12, we pretty much want to focus entirely on just applications of integrals. So now that we can find the area under a curve, now that we can find antiderivatives, what different types of business applications are there for this particular piece of mathematics? So the first thing we want to look at as we work towards these income distribution problems is we want to set up the idea of how we find the area between two curves. So given our two functions here, e to the x, which is in blue, and x squared, which is in red, let's say we wanted to look at the area under these curves between 0 and 3. We would already know how to find the area between our function e to the x and the x-axis on that interval from 0 to 3. And that would just be taking the integral from 0 to 3 of e to the x dx. And let's say that would give us some area A. So this would be this area below the curve of e to the x and above the x-axis. So we also know how to find the area between x squared and the x-axis. And again, if we're still considering over the interval from 0 to 3, this would be the interval from 0 to 3 of x squared dx. And we could call this some area B, whatever that final result ended up being. So when we calculate that, what we're finding is the area of this shaded region, again, bounded between x squared and the x-axis. So those are two types of problems that we already know how to solve. In this module, what we want to talk about is how we find the area between e to the x and x squared. So what we're interested in this case is the area between those two curves on this interval from 0 to 3. So the question is, how could we find that? So if we wanted, we could call this shaded area in blue, whatever that area is, that's some value c, and we could calculate that by first finding the entire area under the curve e to the x. So if we started off with that entire region, and then if we subtract out this shaded section in red, what that would leave us with is just that original section that we shaded in blue. So if we consider this whole area, but then cut out anything under the curve x squared, what we're left with is just that shaded region that we're interested in. So if we start with this area A that we came up with, and subtract out the area B, what we're left with is this area C, that area bounded between those two curves. So to find the area between e to the x and x squared, we could evaluate the integral from 0 to x of e to the x dx minus the integral from 0 to 3 minus the integral from 0 to 3 of x squared dx. Or using properties of integrals, we could just rewrite this into a single integral expression and say that this is going to be the integral from 0 to 3 of e to the x minus x squared dx. And whatever result that is would be that area C that we're interested in. So to find this area bounded between the two curves, we're just going to take the area under the curve with the higher function value and subtract out the area under the curve for that lower function value. And that ends up being our theorem for the area between two curves. So if f and g are two continuous functions, and f of x is greater than or equal to g of x, So meaning all of our function values for f are greater than all of our function values for g on some closed interval from a to b, then the area bounded by f and g for a less than or equal to x less than or equal to b is given by the integral from a to b of f of x minus g of x dx. And again, the order is going to be important here because we need the function that comes first to be the function taking on larger function values. So in the example above, we took e to the x minus x squared because e to the x on this interval from 0 to 3 was always taking on larger function values than x squared. So we need to make sure when we apply that definition that we're looking for which function has the greater values on the interval that we're considering.